Welcome to Session 3. In this session, we will be introducing 2D machining and the many uses and applications in industry. We will deep dive into equipment and materials most commonly used for this type of product development. Similarly, we will talk about some of the machines that are currently accessible to you locally. This session covers 2D machining. So what does it mean to fabricate something? Well, to start off, fabrication is the action or process of manufacturing or inventing something, a product. In this case, when we are talking specifically about 2D fabrication, we will be creating these inventions in a two-dimensional space. Thus, the product we make will be created in reference to the X and Y axes. There is something that we have been doing our entire lives that occurs in 2 dimensions. That action is the process of writing on a blank piece of paper. The flat piece of paper represents the space for the X and Y plane. We can move left to right along the X axis or up and down along the Y axis. But there is one additional action that we need to consider. We don't simply drag our hand across the paper as we write. We continuously pick up the pencil away from the paper and put it back down as we write. Thus, we can say that our hand is creating the Z-axis as we move towards and away from the paper. Similarly, 2D fabrication works in the exact same way. Our initial material will be laid flat, and that will represent our X and Y plane. But in addition to that, the machine will act like our hand, moving towards and away from the material to create that final product. Today, we will be covering some commonly used machines that focus on 2D fabrication. We start off our list with laser cutting and laser engraving, CNC routing, and die cutting. Let's talk about the first machine on the list, the laser cutter. A laser cutter is a machine with a high-powered laser beam. The laser is used to cut and slice materials like wood, paper, cardboard, cork, acrylics, leather, and metals. Laser cutters follow a path determined by computer software. The machine will understand and follow a coded set of directions and instructions, including path coordinates and machine functions. Similarly, a laser cutter machine can be used to engrave. The same laser beam would be used at a lower power to engrave and not cut the material completely. The power at which the laser will be set to engrave will depend entirely on the type of material. This will be important to remember if you are planning on using a laser cutter for your prototype. Because laser cutting and engraving are so precise and accurate, these methods are often used to create custom labels and logos on many different materials. Information like barcodes and QR codes can be engraved onto medical devices or electronics, and may even be used to create unique identification systems within an organization or industry. Medical devices like stents, bone reamers, and catheters are all common examples of laser cut materials. The CNC router is a machine used for cutting. CNC stands for Computer Numerical Control. This means that the machine is instructed to follow specific tool paths as it cuts the material. CNC machines can cut materials like wood, composites, metals like aluminum and steel, plastics, glass, and even foam. Common uses for CNC machined parts include high-strength and low-weight applications. For example, carbon fiber and other composite metals are often used in the aerospace industry due to their ideally low weight-to-strength ratio. CNC machining can also be used on materials like foam to create custom packaging inserts. Surgical equipment, orthotics, and implants are just a few medical applications of CNC machined parts. CNC machining is also used for rapid prototyping, mold making, and even post-processing parts made by different fabrication methods. A die cutter machine uses a specialized machining tool to cut low-strength sheets of material. Die cutters may be manual or digital. Digital die cutters use computer software to cut out original or preloaded designs. A die machine can cut sheets of rubber, foil, textiles, paper, vinyl, foam, sheet metal, plastics, and cork. Die machines do not only cut, but also draw, pierce, engrave, emboss, score, and perforate materials. Some common applications of die-cut materials include custom packaging and labeling, textile and clothing cutout patterns, leather goods, stencils, and medical adhesive tape. In addition to the many uses of 2D machining, it is also important to note the advantages and limitations of fabricating with these methods. 2D machining provides high flexibility of design, allowing for incredibly intricate features. This form of manufacturing produces highly accurate and precise designs, which can be reproduced continuously with the same level of quality. 2D machining also offers a wide variety of available materials, like wood, metals, plastics, and composites. There are limitations that should be considered when using 2D machining for fabrication. There are size limitations depending on the type of machine being used. There are also limitations to the thickness of materials when laser cutting and die cutting. Utilizing the design software requires some level of skill, while operating the machinery requires a skilled, trained operator. These machines can be dangerous if they are not used as designed, and some materials may release dangerous fumes as they melt. In the next videos, we will explore more about the laser cutter machine and the CNC machine.